This one, okay. Let me show you this one. See, you can see this picture here. I showed you in the first class of this class, first lecture, and that shows skin of the ship and also internal structure. But at the skin, you see that there are steel plate that is coming from the steel making company. Right? But some of them in the middle part, they use the whole steel plate as a rectangular. But near the front part, you need to have cutting them into smaller pieces. And then also making a curve. So that is the idea. All right. And then this one. Oh, already done? All right. So this is the offset table. At the top, you're saying that table of offsets. Right. That is shown in here. Oh, no. Should be somewhere in here. But not on this drawing, but offset table should be coming from together. Right. All right. So that's it for the first part of the lecture. And then we can have a discussion session with led by Adib, please. Oh, I need to have you. Adib, where is Adib? Here it is. Okay, let's go ahead.
Can you see my screen?
Yes.
Yeah.
So for this discussion session, I was thinking about how advancement in computational technology can change how shipbuilding processes are right now. So in the next slide, the professor is going to teach us about using different computer software to design the ship. And I was reading this research paper about how neural network, artificial intelligence, and a collection of a lot of data is helping in predicting hydrostatic and hydrodynamic patterns in the sea. So I was thinking, would it be possible to have an AI-based shipbuilding software which can suggest you ship design, like it can suggest you what kind of hull shape you need for for a quality that you want out of your ship. So like I wanted you guys to tell me, like, do you think it's possible, and do you think like advancement in computation can how do you think advancement in computation can change the shipbuilding industry?
I think AI in building shipbuilding is possible, but the hard point is AI doesn't explain why I do like this shape, why I make this shape. So it cannot explain the shapes, and it's the weak point of AI-based shipbuilding system.
Yeah, maybe we can use AR or VR, virtual reality, to track the whole production flow. So I don't know if AI automator can suggest the ship design, but if you input the data of the ship design that have been designed by human beings so far, maybe it can suggest optimization. But in addition to that, I think it will help virtual reality based production platform will allow one to track the whole production flow, and that way it can help like the fast to make the process faster. It will also allow us to monitor the materials in other blocks. So I think overall it will help. It will make the design process optimized. Yeah.
I think that the GPU technology can help us to design the ship, because when we design the ship is using for the computer simulation that the ship power is safe or not, but it took a long time for calculating safety using CPU. But the GPU technology using CUDA core can speed up the calculation of safety, and I think it can help to design the ship power faster.
I agree. I agree with that point. As computer power develops, the complex calculation will be possible. For example, if the ship resistance analysis using CFD is completed in 1 hour, it will be a great contribution to hull optimization. Also, if we use big data about hull history, we can optimize the hull design by using the accumulated hull databases. And in terms of the artificial intelligence system, we can reduce the instability that may occur in human experience-based design, and we can reduce the human error by using the artificial intelligence system. Yeah.
Also, yeah, like the points made are really good, and actually, like in the next lecture slide, there's a video about how development approaches are changing. Like before, like it was only experimental, then it became theoretical, and now people are trying to approach shipbuilding in both the theoretical and experimental processes. So since the fact that this kind of big data can help and artificial intelligence can help in pattern recognition, maybe it can give us an approach where we can make good ship, but as Yu-Sang mentioned, we don't know we don't know the explanation for it. So I think this is an interesting topic to think about. And the next discussion topic is about streamlining ship manufacturing process. So far we have noticed that most ships are manufactured on a custom basis, depending on the customer choice. So I was thinking, why is the shipbuilding process not similar to, for example, say making an aeroplane or cars where you have a standardized design and basically a huge assembly quickly manufactures a ship. Like, why do you guys? What do you think is the advantages and disadvantages of mass producing ship instead of having custom orders?
maybe I'm not sure why the reason we don't have like a standardized design for ships, but maybe if I can speculate, maybe that's because if you compare cars and ships, cars are used by on the individual level. So people like across the world, there are 7 billions of people, and we can say like 20 or 30% of those people can afford to buy a car. That means we need still like hundreds of millions or billions of cars. That means if you can just make a lot of cars, people are going to come and buy. But when we come to ships, the demand for ships is in fewer numbers, so maybe hundreds or thousands. That means if you just produce a lot of ships and put it there, there may not be a demand because there are few parties that are interested in having ships, maybe governments or companies. So I think the demand from those parties would be like so specific. I think that may be the reason we don't have a standardized ship design.
Yeah. Regarding the mass production method, as production method in materials could be standardized, cost can be reduced, and production time surely could be shortened. And in terms of custom order, in general, shipbuilding is customized by client or each client. So by using the custom, in terms of custom order, it can reflect the specific site condition, and it can reflect the specification designed by the client's special order in detail. But it could takes a long time to building the ship, build the ship. And, yes.
Anyone wants to say anything about it? Anything else? Okay, I guess not. Well, yeah, I think the points mentioned are very valid points, that there are not as many ships as cars. So maybe that's a good point. But again, if we were to consider that point, it's also similar to the aeronautical industry as well. So yeah, I think it's something to think about. But given the fact that even having an equipment on a for a ship, we cannot just install an equipment in any place because it will change the center of fluency. So maybe there is a reason for having custom orders. So I guess with that we can end today's discussion session. Thank you everyone for giving your feedback.
Thank you.
All right. Thank you. Good topics. I have several comments on this. First of all, Gihan, you need to have such a microphone because your speech is not clear to us. So next time, I hope you can provide some device for better communication. And about the computer application to shipbuilding, there are many researches already, technologies too. So I send you one image through the Kakao, where there is a conference called KAIST. There is a computer application in shipbuilding. You may find out more, but there are more than this conference. Anyway, many computer technologies used in shipbuilding and ship design nowadays, including AI, VR, other things, big data. Right, about the second topic, yeah, the key is demand and supply. As Burkett pointed out, there are not so many demand. So if you think about, say, semiconductor manufacturing, they call the order size or lot size. Lot size is LOT. Lot size is for the manufacturing. The order is coming. So such simple semiconductor is order is coming, such as please provide me 100 million pieces of this semiconductor. 100 million pieces of the same design, same specification. Right? So they make a mass production. 100 million of them. And then it go on to smartphone. My smartphone. Probably Samsung produced this kind of same model, probably 100,000. Right. 100,000. How about car? My car, same model. The Hyundai Motors, they may manufacture probably several tens of thousands. Or same car. Right? But for the construction, building construction, this building, I am located in this building. This one is unique in the world, right? No mass production in construction industry. How about airplane? Airbus, probably they produce hundreds of them. Not many thousand, hundreds. So there are so many layers of demand amount. That is the key difference. Now, but as Sung-min pointed out, the standardization, mass production is good for manufacturers. So in construction area industry, they develop another idea of called modular construction. So module is a piece of building. They produce same one from the another factory and bring them and put them together. Something like a window module, because big building, the window looks similar, almost same, right? So it looks like a tile, big tile. They put them with the window module all together. And also you may think about the toilet module of a hotel facility. Toilet can be same, about half of the rooms, not luxury rooms, regular rooms, right? So the toilet module can be fabricated in the factory and bring them at the construction site. So that modular idea is used many. And in shipbuilding company, they use different wording, same idea. They call this is a block, shipbuilding blocks. That is same as module. Right, okay. Any further question? What is written in here? Korean government has recently invested on smart shipyards, right? There is a big project on using computer application.
Yeah, I found that an article related
Right.
to the first part of our discussion.
Right.
Yeah. Smart shipyard, I think it's called
Right.
KAIST. It was
Right.
interesting.
They trying to use many new ICT technology for the shipbuilding company. All right, good discussion. Then we may move on to next part of lecture material. Lines 2. All right. Sharing. Okay. So second part of lines. So whole design, how can you generate lines drawing, the design sheet? So fairing, as Adib make a question, because I replied as we should make the curved surface into smaller pieces, and then smaller pieces can be similar to a flat surface. And then by making a highly curved surface using approximated small pieces of flat surfaces, then edge of this stitching surface is probably not curved, right? So that fairing is to make a surface more smooth. So that work is done in our days as a designer. So that is not remove an abrupt changes in curvature, right? Smooth fairing, and then so, and also when I was a student, I drew the lines drawing in a classroom. So in that case, the body plane, water plane, and buttock lines, they are not fitting together well. There are small differences coming because of my skill is not good. So adjusting the three major lines between them, the front X view, Y view, and Z view, there is a body plane, water plane, buttock plane. They are not corresponding each other. So they should be done until their intersections are in agreement. But nowadays, computers are doing well, much faster, much better, much higher quality. So surface fairing using mathematics and computer is now popular. So you don't worry about this one anymore as a designer. So NURBS is one of the mathematical surface equation, full name of non-uniform rational B-spline surface, very complicated equation. But anyway, these are used inside the computer system to generate and modify and design a curved surface. And in old days, we use this kind of tools to draw the curved surface. Actually, curves, not surface. Curves are represented as a series of lines. So we call this as a lines drawing, curve drawing. So there are so many different small pieces of tools. And also we use spline. Spline is this red lines here. This is one piece of the curved surface line of the ship. You can see that the other curves here, right? And to draw this curve, you need to have a plastic button. We call this is spline. And then we need to have a very many steel weight or lead weight to put them, fixing them in a curved shape. We call this is a fairing tool and using spline. And then we can put a pencil to draw the line. When I was a student, we do this kind of work. Any more detail, right? Because each curved line is already here, right? We need to draw this curve. But you see, small differences can create a big difference in real shape because it's a minimized curved drawings. So you should be careful on this. But nowadays computers are doing that. So for the mathematics, we call it a tuft or porcupine. This is a drawing of curvature as a linear dimension. The length of the line of porcupine, it shows